Hello my dear students, hope you are all doing fine. Today we will see the remaining portions of the first chapter, that is chemical equations and reactions. So shall we start now? Okay. So till now you studied how to balance a chemical equation. For example, if I write an equation, iron plus water gives Fe3O4 plus hydrogen. This equation you have balanced in the hit and trial method as well as in the usual method. That is why I am taking this equation. That is, you are familiar with this equation. But by seeing this equation, you are not getting any additional information. Correct? That is, whether the iron is reacting with water, or water can be in three states like solid, liquid and gas. So there is no additional information we are getting by looking this equation. So today's topic is how to get a chemical equation more informative. Or by looking at this equation, we will get more information other than simply the reactants are getting converted to products. Now first we can have the physical states of reactants and products to be included in the chemical equation. So physical states of reactants and products. Now what do you mean by physical state? Physical state means, as you know, water has got three physical states or states of matter, that is solid, liquid and gas. So you are representing, or you can denote this physical state by symbols like S for solid, L for liquid, G for gas and also one more thing, AQ for aqueous. You know what is aqueous? Aqueous means a solution in water. Now, if we coming back to this equation, iron plus water giving Fe3O4 plus hydrogen, you know iron is a metal, so it can be in a solid state. So I can write like S in bracket. Now what about water? And you know iron cannot react with cold water. So if this reaction has to happen, iron can only react with steam or hot water. So you can represent the hot water or steam by the simple G, which is gas. Now what about this iron oxide? That is in the solid state, so you represent it as S. And what about hydrogen? Hydrogen is in the gaseous state, so you represent it as G. Now if you look at this equation, you can have an idea of what? The physical state which represents this reactants as well as the products. This is one way. Now, if you want an example for an aqueous, I can also write Zn plus H2SO4 gives ZnSO4 plus hydrogen. Okay, you just balance this equation. This is 3 and this is 4 and this is 4. Okay, you have already balanced. Okay, now see this equation, Zn plus H2SO4 gives ZnSO4 plus H2. Here you know zinc being a metal, you can write it as solid, but what about sulfuric acid? This you can write it as aqueous because we dilute the sulfuric acid. So it is a solution in water. That is why we are writing aqueous or AQ. Now what about this zinc sulfate? That is also aqueous and hydrogen is a gas. So this is the example for the physical state which represents an aqueous solution. So this is one method by which we can make this chemical equation informative. Okay. Now what about the second method? Second method is we can represent the chemical equation by saying the chemical conditions. You can represent an equation by saying a chemical conditions. Now what do you mean by chemical conditions? Chemical conditions means in which condition will the reactant get to product. Now there are mainly three types of conditions. One is pressure, second is temperature and third is catalyst. There are also so many conditions, but for here this thing only 3 conditions we are taking now. So now if you go for pressure, you see there is an example, I will tell you. CO plus hydrogen will give you CO plus hydrogen will give you CH3OH. Okay, what is CO? CO is a gas. Hydrogen is also a gas, and this is methyl alcohol. You will study in the 4th chapter, organic. Okay, methyl alcohol. Okay, so this is a liquid. Now I will balance it. 2H2 3 plus 1 4. Okay. Now if this reaction has to happen, this won't happen at standard temperature or pressure. This reaction will only happen if you give this reaction at 340 atmosphere or pressure. Only then this reaction happens. So that is a condition. Only you apply 340 atmosphere. Atmosphere means pressure, you know. Pressure can be you can have pressure so many units like atmosphere, then bar, torr, etc. So only at 340 atmosphere this reaction happens. That is why we say chemical conditions. Okay, so this is an example for pressure. Now we look for temperature. Then I can write the decomposition of KClO3. What is KClO3? KClO3 is potassium chloride. Okay, now this decomposes to form KCl plus O2. Correct. Now if this reaction has to happen, we have to give heat or some temperature must be required in order to decompose this potassium chloride to potassium chloride and oxygen. Okay, so that is the condition by which a reaction happens. Got it? Okay. Now the third condition is catalyst. You know what is a catalyst? A catalyst is a substance which speeds up the reaction or alters the rate of a reaction. Now, for an example of a catalyst, you have studied photosynthesis, right? In biology, that is carbon dioxide plus water gives C6H12O6, that is glucose and oxygen. Okay. Now, in order to have this reaction happening, you have to have a catalyst. So, before that you will balance it. So, 6CO2 plus 6H2O giving C6H12O6 plus 6O2. And we will have the physical state also, that is this is aqueous, this is liquid, this is again aqueous, this is liquid. Okay. So in order to okay, so in order to have this equation, you need a catalyst, that is what? Sunlight is necessary for this catalyst. Okay. So this is an example for what? Catalyst. So you got the 3 points, that is these are the reaction conditions in which a reaction happens. Okay. Now, so you got this. Now the third one is by putting an arrows like an upward arrow or a downward arrow. Okay. Now, when we will put this upward arrow, if there is a gas in the equation, for example, see in this equation hydrogen is evolved. So, if there is a gas evolved in this equation, we can put like an upward arrow. Correct? Now, when we will use the downward arrow, we will use the downward arrow if there is a precipitate. Now, what is a precipitate? Precipitate is an insoluble substance. Precipitate is an insoluble substance. So, whenever a precipitate occurs in a reaction, then we will put a downward arrow. For example, if you see the reaction lead nitrate plus potassium iodide, you will get lead iodide plus potassium nitrate. Now in this equation, you will get an yellow precipitate of what? You will get an yellow precipitate of lead iodide. I think I have shown this in the class, this experiment. Okay. So this is the downward arrow and this is the upward arrow. So you got this, how you can make a chemical equation more informative. Okay. Now, as I said that the physical state of equation, it is informative, but normally when you write an equation, we won't put this physical state unless the equation demands it. That is why I wrote this special equation. For example, if you simply write it Fe plus H2O gives Fe3O4 plus hydrogen, you can write like that. But in this case, you have to put what? You have to put this physical state as gas. So that is why this is important. Okay. So this is about what? This is about how we can make a chemical equation more informative. Okay. So I hope you understand this. Okay. Now next topic, going into next topic, that is types of chemical reaction. Types of chemical reaction. Okay. Now you know what is types of now you know what is chemical reaction, right? Now that is reactants getting converted into products. You have to study 5 chemical reactions, out of which the first one we will discuss today, that is combination reaction. So we will deal with combination reaction today. As the name itself indicates that combination means combined together. For example, if I am writing A plus B giving C, you know the one which is in the left hand side is the reactant and one which is on the right hand side of the arrow is the product. So how many reactants are reacting? 2. So 2 reactants react together to form a single product, then you will call this reaction to be a combination reaction. Understood? Once again I will tell you, if 2 or more, you can have more, but 2 has to be there, right, for combining. So when 2 or more reactants combine together to form a single product, then you can say this reaction is a combination reaction. Okay. Now for example, we will see calcium oxide plus water. Now what is calcium oxide? Calcium oxide, you say it is quicklime. Okay. When quicklime or calcium oxide is treated with water, you will get calcium hydroxide. See? Now what happens in this reaction? In this reaction, 2 reactants are reacting or combine to form a single product. So you can say this is an example of a combination reaction, isn't it? Now one more example, if you see magnesium plus oxygen giving magnesium oxide, right? Why? Why? Because magnesium and oxygen are 2 reactants combined together to give a single product. That is why we say this is an example of a combination reaction. So you understood? Okay. Now again, if I look at this reaction, in this reaction, a tremendous amount of heat energy is liberated. That is, this reaction is taking place vigorously. Okay. Or if you take a beaker, you put some calcium oxide into it and you pour water into it. If you touch the beaker, you will feel some warmth in this beaker. What it indicates? It indicates the heat is evolved in a reaction. Okay. So I can write calcium oxide plus water giving calcium hydroxide plus heat or heat energy. Okay. So now how will you define a combination reaction? You can define a combination reaction when 2 or more reactants combine together to form a single product. Now This reaction has got some industrial application, you know. Now, what is this calcium oxide? This calcium oxide is called as slake cut lime. Slake cut lime. You know for what purpose slake cut lime is used for? It is used for whitewashing. You know what is whitewashing, right? Okay. Now, what happens in whitewashing? You put this calcium hydroxide in the walls. Okay, you apply this calcium, the aqueous solution of calcium hydroxide in the walls and leave it like that. Then what happens? Then you can see after 2 to 3 days, the walls will be having a shiny appearance. Why is that so? Why? Because this calcium hydroxide or the slake cut lime reacts with the carbon dioxide in the atmosphere. The process is very, very slow. That is why I said after 2 to 3 days you can have that finish, that shiny finish. Okay. So calcium hydroxide react with the carbon dioxide in the atmosphere to form calcium carbonate plus water. If you touch it, you can have a moisture feeling there. The walls will be shiny. It will have a shiny finish of that. Okay. So that is its application. So the combination reaction, that is 2 or more reactants combined together to form a single product. Understood? Okay. Now we will see some examples of combination reaction. This much you got it? Okay. Now, examples of combination reaction. Examples. Okay. First is burning of coal. Okay. Now, in burning of coal, that means carbon. Burning means what? Burning means in presence of oxygen, you will get carbon dioxide. Here also, I will write heat. Okay, carbon plus oxygen will give carbon dioxide. Now, balance it. 2. No, it is already balanced, right? Okay, carbon dioxide. So, this is an example of a combination reaction. You know why? Because 2 reactants combine to form a single product. Now, second is what? Second is, if you write hydrogen plus oxygen, the formation of water. See, hydrogen plus oxygen, you will get water. Okay. Again, I will write heat. Now, the third example, burning of methane. You know what is methane? Natural gas. Burning of natural gas. What is natural gas? Natural gas is methane. Now, methane, burning means what? Reaction with oxygen. Combustion you say, right? Okay. Now, burning of natural gas also gives what? Carbon dioxide plus hydrogen plus heat. See? What do you observe in all these combination reaction? You see, heat is produced in this reaction. Okay. Now, since heat is produced in reaction, these types of reaction we call exothermic reaction. Why? Because thermal means heat, exo means evolved or liberated. So, such a reaction in which heat is evolved or liberated along with the product is called as an exothermic reaction. Okay. So, now again there are so many examples of exothermic reactions. Okay. One more I will write, that is burning of natural gas, methane, that is methane plus oxygen giving carbon dioxide plus, this is enough. Okay, right, 3 is enough. Okay. Now, then one more type of exothermic reaction is what is called as respiration. Now, we say respiration is an exothermic process. Now, how can you say respiration is an exothermic process? This question is asked for board exams. Okay. You know, respiration is a burning process of food in body to produce energy. We all know that energy is required, right, for our living. So respiration means it is a burning process of food, if I say. Okay, it is a burning process of food. Chemically, I can say it is a combustion of food, correct? Now, combustion means what? Combustion means reaction with oxygen. So, something is getting react with oxygen to give us energy, that is it. So, how is this possible? You know that we need energy for living, and where does this energy get from? We get this energy from our food, isn't it? Now, if we eat food, it will get digested, and the food is getting broken down into simpler products, correct? Simpler products. For example, if you say carbohydrates, carbohydrate means which food? You are using what? You are using like rice or bread. All this contains what? Carbohydrates, right? So, in the carbohydrates, in digestion process, this carbohydrates is broken down into what? It is broken down into the simpler substance like glucose. How this happens, you will study in biology by means of enzymes and all that. Okay. Now you got a simpler substance like glucose. And this glucose react with oxygen in the cell. There is the process. Here comes the burning process or the combustion process. So this glucose react with oxygen in the cell, giving out a large amount of energy, or you can write heat energy. You got it? So this, since energy is liberated, you can say this process is an exothermic process. So now you can say respiration is an exothermic process. And this heat energy is stored in the form of ATP that you will study in biology in chapter 6, I think. Okay. So once more I will say respiration means nothing but the burning process of food. Now how you can say it is a burning process of food? The food is broken down into simpler products like glucose. Then the glucose will react with oxygen in the cell. Now then liberating a large amount of heat energy which is stored as ATP. So that is why respiration is called as an exothermic reaction. Got it? Okay. Then if a question asks, give a reaction which is both a combination reaction and an exothermic reaction, what will you do? What will be your answer? Give a reaction which is both a combination reaction and an exothermic reaction. You can say what? Carbon plus oxygen giving carbon dioxide, right? Plus heat. Okay. So this is all about what? Exothermic reaction. Now, you got this? Okay. Now, there is one more reaction called as endothermic reaction. That's all. Endothermic reaction. Now, what is exothermic? If heat is evolved or liberated during a chemical reaction along with the product is called as an exothermic. Now, what will be the endothermic? If the heat is absorbed during a chemical reaction, you call that reaction to be an endothermic reaction. For example, in the decomposition, I already told you, for example, the potassium chloride, it needs heat for decomposition. So the heat is absorbed by this reactant to form what? The product KCl plus O2. So this type of reaction is called as endothermic reaction. So you got this?